So in this lecture, we will see the basic concept of spatial analysis and different kind of tools available for such kind of analysis. So learning objective of this lecture is to understand the concepts of spatial data retrieval, spatial data classification and measurement operations. Learning outcome of this lecture is that at the end of the lecture you should be able to answer the following questions: what is spatial data analysis, what is so important about spatial data analysis, different components of spatial data analysis, and different types of operation, different steps available in the software, what kind of tools are available for spatial data analysis. So these things you should be knowing at the end of the lecture. That is overall expectation from this lecture. Before starting the lecture, just think about these questions. Like distance of the nearest hospital. So if you have to calculate such, if you have to do such kind of analysis like finding out distance of the nearest hospital, how this is done, and route to the nearest hospital, how this route is calculated. Then suppose this finding out distance of nearest hospital, finding out shortest route to the hospital. These are the things which we can do or which usually do using your mobile phone in Google Maps. If you have to visit some restaurant or some tourist place, you just search the name and Google Maps shows you the distance as well as the nearest route to reach to that location. But suppose you have to find out nearest school which is 100 meters away from major road. This is the kind of analysis which is not usually ready-made available in Google Map or other platforms. So for this analysis, you need to have the spatial data. What kind of spatial data you need? Since your objective is to find out the nearest school which is 100 meters away from the major road. So you need to have the location information of schools, you need to have location of roads. Then only you can perform this kind of analysis. And apart from these locations, you need to have software which is able to handle these kind of spatial data and the analysis. So similarly, you can use these tools to make the hazard zonation map. You can use these tools to find out a suitable site to establish some particular kind of industry. You can find out the suitable place to build your own house. You can find out the suitable place to build new school. You can find out suitable site to build new hotel. Because when you just think about uh, buying a land or new house, what do you need? Do you decide these kind of questions based on certain criteria, like distance from the city center, distance from the road, what is in neighborhood, and distance from the schools, distance from the market, price. Based on many criteria, you decide to purchase a land or house. Similarly, if you have to establish an industry, if you have to establish a school, there can be different set of criteria. Like if you have to establish a school, that should be accessible to the students. That should be easily accessible, means easy transport should be available to the school, means road availability should be there, and the school should not be in very remote area where nobody wants to go, where distance will be too much for the students to travel. So that should not be there. So distance is another criteria. And if you are establishing a school, so obviously you should establish in a region where existing schools are less, then it will be better. So you need to find out demand where a new school is needed. So these kind of criteria can be included. Ultimately, you can end up with a better decision with the help of GIS. So spatial data analysis is the process of extracting information from spatial data based on the given set of requirements. These requirements can be like these which we have discussed just now. So what we are extracting here, so if you see, finding out the nearest school which is 100 meters away from the major road. So getting the information of school, location of the school, that is the information we are extracting from the spatial data. Here spatial data is major road and school. So similarly, there can be analysis based on spatial queries. So here, whatever we are doing to find out where school within 100 meters from the major road, that is a kind of query. Query means we are searching from the existing data. The school data was available, the road information is available. We are just searching from that database that which school is 100 meters away from the major road. So this is query, but at the same time, this query is based on location of the road as well as location of the school. So that is why this is called spatial query, or also known as location-based queries. Means queries where location of the feature plays a role. There can be non-location based query, like find out the cities which are having population more than 1 million. So that is a kind of query. That is again a kind of query. Your data will have the population information, and based on that you are applying a filter to select the cities which are having population more than 1 million. But in that case, the query does not need any special information, so that becomes non-spatial queries or non-location based queries, also known as attribute query. Means the query which is performed based on the tabular information, not the location information. So there can be network analysis. Network analysis is also one of the spatial data analysis. In the network analysis, we find out the shortest route from the source to destination, shortest route from your location to the tourist place, shortest route from your location to some particular training center. There are other kind of analysis like service area analysis, closest facility analysis. So closest facility uh, analysis, suppose you have to uh, cater for the need of emergency services. For example, you are the person which is responsible for providing the ambulance service. So, an ambulance is a kind of thing which is needed urgently at the spot. But city is not very small; it is significantly big. So, you need to place ambulance at some designated places in such a way that any point in the city should be covered by the ambulance within 10 minutes time or 5 minutes time. So which means each point in the city should be serviceable within 10 minutes, for example, from the ambulance. So that kind of planning can also be done using network analysis, using closest facility analysis. In closest facility analysis, the distance from source to the travel time as well as distance from the source to the facility is calculated. So if you are putting a criteria of 10 minutes from each location, so if there is no designated ambulance spot within 10 minutes distance from any location, then you can propose that this is the new location which is not serviceable within 10 minutes from the existing ambulance service. So new spot can be designated for better public service, public health. That is one example where GIS can play a role to make better informed decisions. Creation of surface from point data is also kind of spatial analysis. The different name is given to that is known as interpolation. So interpolation is one of the methods which generates surface from the point data. This kind of thing is required for the data which is continuously changing. Continuously changing is the kind of data which is field phenomena. So you, from the previous lectures, you have seen the concept of field and object. So there is a concept of continuous as well as discrete field, and there is a concept of object. So you can make a polygon, you can define the boundary for discrete field, you can define the boundary for an object. But in case of continuous field, you cannot define a particular boundary, for example, temperature, elevation. So these things are changing continuously from one location to other, irrespective of pixel size. You can keep pixel size as small as you want, but temperature is continuously changing, gradually changing. So if you have to map this kind of phenomena, so there are two methods. One is satellite-based method, where you capture information for each pixel. But when it comes to ground-based measurement, so you cannot collect the ground information for each pixel, because collecting ground and going to each pixel and collecting the information becomes very difficult task for human being to perform. You just imagine if you have to make a temperature map at 30-meter resolution. So in that case, you have to travel each 30-meter block and collect the information. So there will be millions of locations which need to be covered and not possible practically. So in that case, interpolation method is used to generate the surface, continuous surface. Those things we will see in detail later. And yes, making prediction is also need one kind of spatial analysis, or better way you can say part of spatial analysis can be used for making predictions. For example, to predict future land use scenario. So these kind of future predictions need all spatial analysis. Yeah, it is important because we extract some meaningful information from the spatial data. These are the components of spatial data analysis. Uh, First component is spatial data. So basically, when you have to perform spatial analysis, at least you need data. So spatial data is basic requirement for the. So spatial data is the basic requirement to perform any spatial analysis. Then comes the computer with GIS capabilities, which means you need a platform, a software, either a desktop-based platform or a cloud-based platform, which is capable of handling GIS data and giving answer to your queries. The third requirement is the third component of spatial analysis is the requirement itself. Means what kind of analysis you are going to do. For example, you are given with the data, road information, school information, land use information. Now what? You are having data, you are having software, but what are you going to do? That should be defined. To do any kind of spatial analysis means you are going to find out the nearest school, nearest hospital, or you are going to predict future scenario. Whatever you are trying to do, that should be defined. So requirement is also a component, important component of spatial data analysis. Then once these things are fixed, known, you need to look for the algorithm or tool which is able to fulfill your requirement. For example, if you have to find out all the schools which are within 100-meter distance from the road. In that case, you need a tool or algorithm which should be able to read the data and apply your requirement in the database query. So, having algorithm is another part component of spatial data analysis. Then comes the visualization part. In visualization part, we actually visualize what we have got from the spatial analysis. Like if you are looking for schools which are within 100-meter distance from the major road, so in that case, visualization will show you in the map form that what is the spatial location of those schools. So types of spatial analysis. The functions for spatial analysis, they are broadly grouped under these groups. One is measurement, retrieval, and classification group of functions. So these functions talk about measurements in vectors as well as raster data. Measurements like finding out distance between 2 points, finding out distance between pixels. So these kind of measurements. Area of a polygon, length of a line or road. Then retrieval. In case of retrieval, the data is retrieved from the desired or suitable data is retrieved from the existing data. Or you can say here in retrieval group of functions, spatial queries, location-based queries are performed. Location as well as attribute-based queries performed in case of retrieval functions. So basically, for example, can be selecting schools which are within 100 meters from the road. Then classification and reclassification functions. These functions talk about classification and reclassification of vector as well as raster data. So the classification and reclassification is needed sometimes to reveal the underlying patterns which are not visible when there is no classification. We will see in detail these things. Another set of functions are overlay functions. Overlay functions are the functions where overlaying of the two data sets is needed. For example, intersection, clipping, erase operations. Then neighborhood functions, the functions which require neighboring pixels, neighbors information. Similarly, connecting functions, connectivity functions. So, for today's session, we will see in detail about measurement, retrieval, and classification. When I say measurement here, it means geometric measurements. The measurements which are based on the location of the features. So these can be the distance if you are having 2 points. So distance between 2 points is a geometric measurement and it is calculated based on the distance formula if you are having 2 points. If you are having 2 points, just a minute. Yes. So if you are having 2 points, distance is calculated based on the distance formula. Distance formula is simple. Square root of x2 minus x1 square plus y2 minus y1 square. So here x1 is the longitude of first point, x2 is the longitude of second point, y1 is the longitude of first point, and y2 is the longitude of second point. So this way, if we are having the geolocations of 2 points, we can simply calculate the geometric distance between the points. Similarly, length of a line is also calculated. So how length is calculated? Once a line is made in GIS, so how a line is made? Line is made by connecting 2 or more points. So we are having 1 point, second point, third point, fourth point. So if you connect these points, you will get a line. So in the software, all coordinates of all these points are stored. Basically, longitude and latitude of all these points are stored. So if you have to find out length of the line, since you know the coordinates, using this formula, length of this segment can be calculated. Using the same formula, length of this segment can be calculated, and for this segment length can be calculated, and if you add up you will get length of the line. Similarly, area, perimeter, once you know the coordinates you can calculate any geometric property. The calculation of length or the calculation of distance between 2 points is different in case of raster as well as vector. So here whatever method I have told, this method is used for calculation in vector data. Now we will go to raster data, but before that let's finish the vector. So if distance between 2 points need to be calculated, that is very simple. You need to use the distance formula, square root of x2 minus x1 square plus y2 minus y1 square. So very easily distance can be calculated in case of 2 points. But if you have to find out distance between a point and a line, so there can be many distances between this, here, many distances are possible. So in this case, fundamental rule is distance between a point and a line is the minimum distance between point and the line. If distance has to be calculated between 2 polygons, in that case also one distance, this kind of distance between the centroids, this distance. There are many ways to find out distances between 2 polygons, but fundamentally it is inbuilt in the software. If you have to find out distance between 2 polygons, again it is the minimum distance between 2 polygons. Bottom of the line is distance between 2 features, either point or line or polygon. It is the minimum distance between those features. It can be point to point distance, point to line distance, point to polygon distance, polygon to polygon distance, line to polygon distance. The measurement of distance is little different in case of rasters, because in case of rasters we do not have points, we have pixels. So instead of finding out distance between 2 points, here distance can be found out between 2 pixels. But if you have to find out distance between, for example, this pixel and this pixel, how you will find out? Because here it is not a point, here it is aerial representation. Pixel is aerial representation. So rule is distance between 2 pixels is the distance between their midpoints here. So this is the little difference between vector and raster based distance measurement. In case of raster, if you have to find out area of a feature, in case of vector, if we have to find out area of a feature, suppose here this is feature 1, this is feature 2. If you have to find out area, so area is calculated with the help of area formula, which calculates area based on exact location of the all the vertices used to make this polygon. But here in this case it is not like that. In case of raster it is not like that. Here area is calculated by this way, number of cells multiplied by a cell size. So if we have to find out area of this feature, which is represented in yellow in color here, so what will be area? How many pixels are used? So 1 pixel, 2 pixel, 3, 4, 5. So total 5 pixels are used to complete this feature. So number of cells 5 into what is area of one cell. So for example, in this case, this is 30 meter by 30 meter cell size. So area of one cell will become 900 square meters. So total it will become 4500 square meters. In case of rasters, as here I have explained, in case of vector like point or polygon, the coordinate of each vertex are stored. But in case of raster, it is not like that. This you may have seen previously also. The coordinate of one anchor point are stored like longitude, x is longitude and y is latitude, and a pixel size is stored like 20 meters, and coordinate for rest of the cells are derived from this information. For example, here coordinate of this anchor point are 1554, that is longitude, and 203538, that is latitude. So if we have to find out coordinate of this pixel center, how will you find out? So here this is y-axis and this is x-axis. These are standard representations. So if you have to move from this anchor point to this center, how you have to travel? 1 pixel you have traveled, the size is 20 meters, so 20 meters you have traveled, then half of the pixel, so 20 plus 10 meters, so total 30 meters travel in x direction. So x value here will become 1554 plus 30, which is 1584 meters. And similarly, what will be the y coordinate? So since here anchor point is this, so if we are traveling in the right hand side, that will be the positive direction. If you are traveling in left hand side, this is negative. And if we are traveling below this axis, that will again become negative. So from this anchor point to reach to half of mid point of this pixel, we will travel half of the pixel distance this way. So that is 10 meters. So here we are traveling in downwards, so which is negative. So that's why y coordinate will become 203538 minus 10, so which is 203528 meters. So this is how coordinate for rest of the pixel are calculated. Then these are the examples of some of the measurements. Now we will move towards retrieval. So retrieval is basically based on searching of the data. The searching can be based on attribute values, and the searching can be based on location of the data. To find out all the cities which are having population more than 1 million. So this is attribute based retrieval, where we are putting a condition over the tabular information. And if we have to address the query like find the length of border of India, so in that case we are performing the query based on location of the border. So this is location based data retrieval. So there are few methods to retrieve data based on location. One is interactive. In case of interactive, we simply see the software and open the software, see the data, and select the desired feature based on simple mouse click. And the next is based on spatial selection by attribute condition. So here in this case, selection is based on the attribute query. We put some conditions like based on the relational operators or based on the logical operator or based on combination of both relational as well as logical operators to uh, select or to retrieve the desired data. Third way is selection using topological relationship. These are the location-based queries. For example, select features that are inside the selection object. Basically, select all the schools which are in particular city or which are in particular ward. That kind of information. And then select features that are intersecting. Suppose you are having a data set of state boundaries and national highways, state highways, roads. So if you have to select all the roads which are crossing the state boundary. So in that case, intersect operation can be used. So wherever there is intersection between the state boundary and intersection of roads, those roads can be retrieved. Maybe needed in some cases. Suppose in some emergency situation, you need to uh, do means the authority need to block all the entry and exit points of a particular area. Generally, all the entry and exit points are known for state or district. For well-defined area, they are known. But suppose entry and exit points are need to be blocked for not previously defined area. So in that case, if you have to identify, so quickly using with the help of quickly using GIS, you can identify the roads which are crossing that boundary and block all those entry and exit points. That is one of the practical applications. Now we will see in detail about these trivial methods. First one was interactive. So here I am showing you one screenshot of the software. Today we will see some demonstration of the software also. But before that, let's see the presentation. Here, whatever structures you are seeing, this is the data, the spatial data. It is called data view or QGIS canvas view, where you can display the geometry of the data. Then there is a tabular information, where you can store the non-spatial information. Also, if you talk about exact definition of this information, so this is the characteristic property of the corresponding features. For example, area can always be calculated using software. Population information you cannot calculate from software, that need to be collected. Population information need to be collected, then name of the ward that also need to be collected from the ground or collected from defined source. So now if you have to select some particular feature, you can simply select by selecting the row or record in the table. Also, you can select by selecting a feature in the QGIS canvas. Since this table and this data, they are related to each other, which means for each feature there will be a corresponding record, corresponding row in the table. So these two are interlinked. So either you are selecting the feature or you are selecting the row in the table, both will be selected. Corresponding feature will be selected and the row will be selected. So this selection you can do for very limited features. For example, if you have to select India, you can simply open the world map and know where is India. You can go and select. Suppose you have to select US. You know where is US, it's very big. You can simply zoom out and select US. But suppose you have to select a very no, all the demonstration will be here in QGIS. So suppose you have to select a island, a very small island which may not be known to everyone. For example, from Indian group of islands, from Andaman Nicobar, you have to select Nicobar Islands. So they are very small and uh, everyone may not be aware where exactly they are. So in that case, it is better to perform the query. Just use the software, put the name, and it can be selected. That is one example where interactive query may not help. Obviously, you can scroll down and search name of Nicobar Islands and select. And another example, suppose you have to select all the cities which are having population less than a million. So if you have to select all the cities from the across the world which are having population less than a million, that becomes a laborious task. You need to scroll down a lot of features, check their population information, and select. So to overcome these difficulties, there is a selection by attribute conditions. So here we put attribute condition in this manner using relational operators less than or equal to less than, this is for less than, equal to, less than, equal to, greater than or equal to. So here field value followed by the relational operator and value. So if we have to select cities which are having population less than a million, so in this case field value population need to be selected. Field value is nothing but name of the column from the attribute table. So population less than 0.1 million. So this way it will select all the features which are having population less than 0.1 million. For does not equal to, this symbol is used in QGIS and this is used in ArcGIS. So if we have to perform just one example, the population less than this number. So if you put the criteria, you can see all the features which are having population less than the number, they are selected, like 6907, that is selected, 6883 is selected, 6935 is selected. More than the 7000, they are not selected. And corresponding feature is selected in the canvas. So you can see 1, 2, 3, 4, 5 polygons are selected here, and here 4 rows are visible, one is not visible, but here you can see 5 out of 45 uh, features are selected. Now come to the case where multiple conditions are there. So multiple conditions can be combined using these logical operators. Now these logical operators are AND or NOT. So they are used to combine multiple conditions. So if there is AND operator, many of you may be aware about this, but anyway I am explaining it for benefit of all. So this is the logical operator AND. So this is combining these two conditions, condition A and condition B. So in this case, a feature will be selected when both the conditions are true. That is the use of AND operator. So here condition is area greater than 100 and population less than 8000. To just take example of first row, here area is 51.98, but our condition was area should be greater than 100. So this condition A becomes false. So if condition A is false, this record will not be selected. I am saying here row and record, they are same. So either you can call row or you can call record, they are same. Field name as well as column name, both are same. Now just come to third row. Here area is 145.01 units. So here criteria was area greater than 100. So this criteria is satisfied. Area is 145 is greater than 100. But the second one, population 8030. So that is not satisfied. Here condition was population should be less than 8000, but here 8030, that is more than 8000. So this condition becomes false. So this is not selected. But if you see others, area 651, that is more than 100, this is correct. And 7630, that is less than 8000, this is also correct. So when both the conditions are true, record is selected and corresponding polygon is also selected. So here instead of polygon, there can be lines also, there can be points. So result method does not change. Now come to OR operator. So suppose this is condition A, this is condition B. So in case of OR operator, it will select the record when both the conditions are true or any of the condition is true. So either A is true or B is true or both conditions are true, it will select the record. So you can see here, first record, area is 51.98. condition A is false, but condition B is true. 7932 is less than 8000. So it will be selected. One condition is true, other one is false. Since it is OR operator, it will select. It will not select only if both the conditions are false. So the case of second row, area is 86.98, that is less than 100. Condition not satisfied. Area less than 8249, condition not satisfied. So this is not selected. Then comes a negative condition, means not operator. In case of not operator, it will select when condition is not true. So not means it will select when condition is not true. So here query was ward name equal to Rajpur. Here you can see all the wards are selected, but wherever name was Rajpur, this is not selected. Here red color means selection and this color means no selection. Here white color in the table means no selection. Red is selected. So you can see 45 out of 44 out of 45 features are selected, and this condition is true for Rajpur, so it is not selected. Again, I am repeating, in case of not, the feature will be selected when condition is not true. Searching for null values, when this way we can search for null values. Is null or is not null. If you are looking for non-null values, is not null, is operator is used. Like operator, so suppose you have to select word name starting with RA. It can be RAMPUR, RAJPUR. So whatever name starting with RA, that will be selected in this case. So in second case, percentage RA, whatever names ending with RA, that will be selected, and percentage RA, percentage, whatever names wherever RA is coming in between, those will be selected. Now we will come to selection based on the topological relationship. Someone is asking if I would cover spatial statistics. Some part will be covered in upcoming lectures, but not today. And these are the 8 kind of spatial relationships: disjoint, meet, equal, inside, covered by, contains, covers, overlap. From the previous lecture, I have seen that you have the brief about these kind of spatial relationships. Quickly, I will show you. So disjoint relationship means there is no touching, overlapping, intersection between the features. Meet relationship means geometries are touching at the boundary but not from the interior, because touch can be this type also, where one feature is touching other feature from inside. So this is not meet. In case of meet, features touch at the boundary but not from the interior. try to answer these questions which are related to whatever we have seen. Which of the following is not spatial analysis? Which of the following which is the component of spatial data analysis? So these things are already covered. You can think here this is the correct answer. Here this is the correct answer. Distance between two cells of raster is, what is the distance between two cells of the raster? Is it the minimum distance between these cells or maximum distance between? No, it is not minimum. Minimum distance concept is there in case of vectors. In case of raster, it is distance between the midpoints. Which of the following will be selected if this query is used? Name starting with RA, that will be selected. So RA is this. It is case sensitive. This will not be selected. This is small r. Only this will be selected. Which of the following is correct about disjoint relationship? So this disjoint relationship we have seen. It is geometries neither touch nor overlap. No touch, no overlap, no intersection. So the first one. Which of the following is correct about meet relationship? Just now we have seen meet relationship is the relationship where geometries touch from outside, not from inside. There is touch, there is no intersection. So I can see some of you are saying intersecting boundaries as the correct answer, but that is not the case. If you see the definition of meet, geometries touch at the boundary, not from the interior. So no, both cannot be correct. There is difference between touch and intersection. In case of intersection, objects cross each other. In case of touch, they simply touch. No overlapping needed. So geometry, in case of intersection, overlapping is needed between the object, but in case of touch, only touching at the boundary from outside. So B is correct in this case. So intersection relationship, in case of intersection relationship, two features should be overlaying, their boundaries should be crossing. So this is the situation for intersection. Overlap relationship. So there is another relationship, equal. In case of equal, both the geometries should be completely same. So one polygon is completely same as other polygon. So this kind of relationship is possible between polygon, polygon, line, line, and point, point, because only a polygon can cover another polygon completely. The geometries will be same for same kind of geometries only. Shapes will be same for same kind of geometry. A point cannot completely coincident with line, point cannot be completely coincident with polygon. So this is possible in same kind of geometries. only. Inside, there is inside relationship where object B is inside object A. So let's say this is object B and this is object A. So here question can be select all the schools which are inside a city. Just focus here, select all the schools which are inside a city. In case of inside relationship, the whatever features which are inside the object, another feature, they will be selected. So here B is inside A, so feature B is getting selected. A is not getting selected. Inside feature is getting selected. The covered by is for the case when there is internal touch. Then comes contains. Here object A completely contains object B. So here again this is object B, this is object A. So here in this case you can see the feature which is outside that is getting selected. So these are two different relationships, inside and contains. In case of inside, we have seen select the schools which are inside a particular city. So all the schools which are inside the city, those schools will be selected. But in case of contains, just think about this example. Select the ward which contains clock tower. So in this case, ward will get selected instead of inside feature. So that is the difference between inside and contains. In case of inside relationship, whatever is inside, that is getting selected. In case of contains, feature containing another feature, that gets selected. In case of covers, again, when there is a touch, instead of completely contains, there is touch, that is covers. Selecting features that are inside selected object. Select all the cities that are, select all the schools that are located in Ward A. So here inside relationship is used. Suppose these point locations they are schools and these polygon boundaries they are representing wards. So schools inside Ward A need to be selected. So first of all you need to select Ward A. Then you can see schools inside Ward A are selected. Now, example of intersecting features, as I told once, select highways that uh, run through Ward A. So, red lines they are highways, and these boundaries, black color boundaries, they are ward boundaries. So, if you have to select the ward which are running through a ward, so you first need to select the ward, then use the intersect relationship. All the features which are intersecting with selected word, they will get selected. So this way you can find out these are the highways which are running through the ward boundaries, and accordingly you can take action to block entry and exit points. Now we will go to classification, reclassification. Just one slide we will see for classification, reclassification. We need to classify the data, either vector data or raster data, to bring out or to reveal the important spatial patterns which are not simply visible when data is unclassified. So classification is classifying the source data, reclassification is classification of the classified data. Uh, Here classified data means the data which is divided in classes, different classes, not the secret data. So just see figure 1 first. Here, this figure is representing about population density of the wards. So you can see each polygon is having their own, each ward is having their own population density, and which is represented here. So easily you cannot get the idea that what are the broad regions which are having greater population density and what are the regions which are having lower population density. So there can be a big legend here corresponding to each polygon or each ward. Suppose you are having 100 wards, so there will be a list of 100 wards and corresponding color here. So it becomes very difficult to get the pattern. But the moment you classify data in the groups of low, medium, and high, can make the classes like if population is ranging from 1000 to 2000 or 0.01 million to 0.02 million, then it is low, then 0.02 to 0.3 it is medium, and 0.03 to 0.1 million, that is high density uh, wards. So that way, once you perform the classification, you can simply see the regions which are having low population and which are the regions having high population and which are the regions having medium population. So very easily you can identify the regions having different group of population. So that is the advantage of performing classification and reclassification. Now with this, I am ending the presentation, and I will show you some demo of QGIS. So as if you have installed QGIS in your system, you can simply open the QGIS now or later, whenever you are comfortable. So when you open the QGIS, you will see this kind of windows, and if you have used the QGIS two times instead of having a blank screen, you will see here recent projects. That kind of list you will see here in tabs project 1, project 2, this way. So this big white color portion. This is known as QGIS canvas. CANVAS. QGIS canvas. Name of the software is QGIS. Only QGIS. That is the name you have to follow. On the right hand side, you can see something that is processing toolbox. Here, group of tools are written here. You can search uh, for some tool if you want. Suppose you want to calculate area of all the features, so you can just type area and corresponding tool will be listed. This is identify result panel. May not be available by default in your view. If it is not available, you can simply go to view and enable that panel. It will come, or this panel comes if you click on this icon. Here, this icon is identify tool. The moment you click on this identify tool, this panel will come. Processing toolbox, if it is not coming, you can enable on this processing tab. Here in this software, vector, raster tabs are available. So these groups are having vector data, tools related to vector data, and raster means tools related to handling of raster data. These tools plus minus, they are standard tools to zoom in. Plus is for zoom in, minus is for zoom out. This and icon, that is for pan, means moving here and there. So now if we have to display some data in QGIS, so there are two ways. One way is you go to this layer. Here on the top side you can see a name layer. And from the layer go to add layer and vector layer. So that way you can add a vector data layer. If you have to add some image, so again you have to do layer and raster layer and choose the raster data, it will be added. That is one way to add the data. Another way is the simple way, where you can simply drag and drop the data in QGIS canvas and it will open. So that's what I'm doing. Drag and drop means click and hold over the data file and drop it. This way. Simple. The data was clicked, hold and drag to here and drop. Release your mouse click. It will add. So this way you can see road layer is added. Here this is the road layer and corresponding name of the road displayed. And if you are not able to see any panel here, you can simply go to view, go to panel and click on the desired panel. So there is a long list of panels: advanced styling tools, browser, layer panel, layer order, result viewer, processing toolbox, log panel. So whatever panel you are interested in, that you can enable. Similarly, for toolbars, you can choose which toolbar you want, web toolbar, map navigation toolbar, or digitizing toolbar. So by the way, uh, these are the panels. This is processing toolbox, one panel, layer is one panel, and whatever you are seeing here, these are the toolbars. So like uh, this one is for digitization of the data, means creation of the data. So digitization toolbar. And here you can see symbology means road layer is displayed with very thin and dull color lines. You can simply change the properties. For doing that, you need to just double click over the layer. It will open the properties. So this is the properties window, and here you need to go to symbology tab and choose the desired symbol. This road file was previously created, so it was already stored with me. From that I have taken, and it is created in a manner which was told yesterday for digitization, data input and editing in GIS. So that way this data was created and used here. So I was saying about the tabular information of the data. So that you can see from here. Just right click and open the attribute table. You will be able to see tabular information of the data. So this is the tabular information, like type of the road, width of the road, name of the road, length of the road. So now suppose you have to select a road based on certain criteria. So for that you need to click here this epsilon kind of icon, that is select feature using expression. You click on this icon. So this will open a window where this one is expression location, where you need to write your expression and click on the select feature. It will select. So let's try to select the roads which are having width more than 24. So for that you need to go to here fields and values. This will list all the fields. Fields means columns. So road width was one of the column. You need to select road width. First road name is selected here. So if you want to select particular road name, you can simply click on the road name equal to particular name of the road and click on select by select feature, it will select the particular road. Here, since all the features are visible, so you are not able to see, but the moment you switch to show selected feature, this road will be visible. You can use this icon to simply unselect all. Now we will select all the roads which are having width more than some particular value. Road width more than 24 is, so now you can see all the roads which are having width more than 24, they are all selected and rest are not selected. So this is how the select feature using attribute is done. Now we will simply move. So the other features are also added here, like intercolleges, points are intercolleges, these polygons, they are what, they are again dragged and dropped here. They can zoom in, zoom out, pan. So now see we will see how to select all the intercolleges which are inside this particular ward. So here location based query will be used. So for that, name of the tool is select by location. Either you can search in this processing toolbox search box, or you need to go to vector. So first select the ward. Since schools inside ward need to be selected, then select by location. This tool you need to select, you need to use. Then select features from intercolleges, and by comparing the features with ward, you need to click on the selected feature only, and how the intercolleges will be selected. You need to tick here the relationship. We have seen spatial relationship inside contains touch, overlap. So whatever relationship you want, you based on that you can simply choose here, and it is selected. So since in case we have missed, I will replay it. So here we wanted to select the schools which are inside that particular ward. So inside relationship need to be used here. So name of inside relationship in the software is within. So that is why this within is selected. Anyway, if you are selecting here intersect, then also you will get the same result